Hi everyone, so welcome to this video. So in this video we're going to be solving a comparison problem. So the problem statement is we'll be given a string as an input and our algorithm has to check whether there is any palindrome possible by removing at most one character from the given string. For example, if we take this input, if we give this input to our algorithm which has this string and the characters are A, B, C, E, B, A. So since a palindrome is possible by removing this character E, our algorithm should return an output as boolean saying as true. So if we see the second example, if we give this string to our algorithm, so a palindrome is not possible by removing one at most one string because it is only possible if we remove two characters R and T. So since it is not possible by removing one character, our algorithm should return false. And if we check the last example, a palindrome is possible by removing this one character called A, which should make the string as DEET, which is a palindrome. So our algorithm should return on output as true. So this is what our algorithm should check and return. It should basically check whether there is any palindrome possible by removing at most one character from the given string. So we'll be solving this problem using two approaches. One is a brute force approach, another is a optimal approach using a two pointers algorithm. In the first approach, we'll be checking whether the given string is a palindrome or not without removing any character. So we'll be doing it by using a two pointers algorithm. So if it is a palindrome, we'll be returning true and it will end over there. And if it is not a palindrome, we'll be returning to through each character of the given string. And for each character, the loop variable is pointing to, we'll be creating a string by removing the character which the loop variable is pointing to, and we'll be checking whether the new string which is created by removing that character is a palindrome or not. And if it is so, we'll be returning true. And at the end of this loop, we'll be returning false because if there is any palindrome possible by removing character, it should have already returned true in the loop. So this is the idea of this approach. So over here we can see the computer program of this algorithm which we have discussed. So this is been written in Java programming language. So this method is palindrome possible is the core method of this algorithm which takes string as an input. So as we have discussed, first we'll check whether this entire string is a palindrome or not. If so, we'll be returning true. If not, we'll be looping through each element of the string and we'll be creating a string by removing the character which the loop variable is pointing to. So here we are creating a substring from 0 to I, so which takes the value from 0 to index I minus 1, and then we are taking the characters from I plus 1 to all the way to last element. So basically we are skipping the character at value I, and then we will be checking whether the new string is a palindrome or not. If it is so, we'll be returning true. And at the end of this loop, we'll be returning false because if there is any palindrome possible by removing a character, we should have already returned true over here. So this is how this approach works over here, and we can see the second method, which will basically take the string and check whether it is a palindrome or not. Over here I am using two pointers. One is starting from first element and another is starting from last element of the array. And I am starting a loop with the condition I less than j, and I am checking whether character at I and j are same or not. If it is not, we'll be returning false. Otherwise, we'll be incrementing I and decrementing j. And at the end, we'll be returning true. Yeah, so this is the computer program for this approach. So here, in the worst case, for every string, we'll be checking the whether we'll be checking the entire loop. We'll be looping through the entire loop again to check whether the string is a palindrome or not. So the time complexity will be like big of n square, and the space complexity will be like big of n, since we are creating a new string in the every loop. Yeah, so this is how the brute force approach works. Now we'll optimize these complexities of our algorithm by using a two pointers algorithm. So here, the idea is to take two pointers or two variables. Let us name it as I and j. So I will be pointing to start of the string, and j will be pointing to last element of the string, and we'll be running a loop with the condition I less than j by incrementing I and decrementing j. So at every step, we'll be checking whether the characters pointed at these pointers are same or not. So if it is not same, if there is any mismatch found, and then in that case, there are two substrings which we need to check. So one is a string by removing the character at I, and other is a string by removing the character at j. So if either of the strings is a palindrome, then we can conclude that the original string which has been passed to our method is a palindrome after removing one character which is at either at j or I. Yeah, so this is the idea of this approach. So this is the computer program for this algorithm, which is written in Java programming language. So this is the main method. This is core method of this algorithm. Is palindrome possible, which takes string as an input. Or here, as we have discussed, we will be starting I from the first element and j from the last element, and we'll be running a loop with the condition I less than j. And if there is any mismatch found with the character at j and I, we'll be checking the sub first we'll be checking whether there is any palindrome possible by ignoring the character I and or ignoring the character j. So first over here we'll be checking whether there is a palindrome possible with the substring starting from I plus 1. So over here we are ignoring character I all the way to index j. So j plus 1 is exclusive. So it will check till j. So, or else we'll be checking the substring all the way from I till the index j minus 1. So j is exclusive. It will go to j minus 1. So here we are ignoring element at j, or here we are ignoring element at j, or here we are ignoring element I. Sorry. Yeah. So if there is any palindrome possible by ignoring I and j, I or j will be returned true. And also one thing we should keep a note here is here we are only checking the substring from I plus 1 to j and I to j minus 1, right? We are not checking these portions from the first element till index I, and the portion from last element till index j or j plus 1. It is because since we will be incrementing I and decrementing j only when the element at I and j match, right? It means that all the values between 0 and I and last element to j are matching. So if we concatenate those two portions, it will form a palindrome. So there is no need to check those portions. So we only the checking the substring is enough. So yeah, so that is the idea. So if there is any polynomial possible by ignoring I or j, will be returning true. If there is nothing, it will be returning true. So at the end of this loop, will be returning true. It is because if there is no need of removing any character, it will basically just incrementing I and j, right? It won't be returning anything else over here. So it will be returning true. Yeah, so this is the computer program for this algorithm. So over here, the time complexity will be like big of n itself, since we are running through this each character only once. The time complexity of big of n, and space complexity is like big of 1, since we are not creating any data structures and returning it right over here. the space complexity will be like constant. So these are the two approaches in order to solve this problem. To check whether a palindrome is possible by removing at most one character from the given string. Yeah, so I'll be leaving this link to the link of the sheet which I'm displaying over here in the YouTube description video of this. So this sheet basically contains many other problems which can be solved using this two pointers algorithm. Yeah, so that's it for this video. See you in the next.